Today, we are going to make a model of an aeroplane that demonstrates Newton's third law and Bernoulli's principle. To make this model, the only materials we need are a sheet of paper, a straw and some clay. First, we cut out these shapes from an A4 sheet of paper. After cutting out these structures, we will fold along these dotted lines. After folding, we get these two main parts of the plane, the wings and the tail. Now, we stick them onto the straw with tape, like this. After sticking on the wings and tail with tape, this is how our plane model should look like. But it is not yet balanced. We need the center of gravity to be under the wings. For this, we add some clay to the front of the plane. We keep adding clay until the center of gravity is right under the wings. Now, our plane is ready. But it's not just enough if the plane goes straight. We need to be able to steer it to make it turn left or right, or maybe even go down. How do we do this though? There are several simple alterations that we can make to our plane to make it change direction. The flaps on the wings, they are called the elevators. They make the plane go up or down. By keeping the plane's elevators up, we can make the plane go up. And by keeping them down, the plane goes into a dive. This on the tail is called the rudder. By tilting the rudder to the left, the plane goes left. And by tilting it to the right, it goes right. Isn't it fascinating how simple alterations to a model can make it change direction? But did you wonder why? Why does this happen? Well, that's where Newton's third law comes into play. Newton's third law of motion states that every action has an equal and opposite reaction. When we tilt the elevators on the plane up, it exerts a force on the air surrounding it and deflects it upwards, which is the action. The air in turn exerts a force on the wings, pushing them downwards, which is a reaction. Since the center of gravity of the plane is under the wings, it tilts on its pivot point and the nose is pointing upwards, consequentially causing it to fly upward. Similarly, when we tilt the elevator downwards, it deflects the air around it downwards and the plane flies down. Now, when we tilt the rudder to the left, it deflects the surrounding air to the left, which is the action. The air exerts a force on the tail and pushes it to the right, which is the reaction. Now, the plane tilts on its pivot point and the nose is now pointing to the left, causing the plane to fly to the left. And when we tilt it to the right, the plane will fly to the right. But why does the plane stay in the air in the first place? Well, that's where Bernoulli's principle also plays a part. Bernoulli's principle states that when a fluid like air is moving at a higher speed, it causes low pressure in that area, and when it's moving at a lower speed, it causes high pressure. This plane is designed in such a way that air flows faster over the top and slower below. When it flows faster here, it creates low pressure on the top and high pressure below. This high pressure lifts the plane up and causes it to stay airborne. What started as a simple paper plane has now turned into an innovative way for me to understand two fundamental laws of physics. Thank you.